Remember when tractors were built to last generations, not just seasons? Today we'll explore some of the most indestructible tractor engines ever manufactured. Let's start with a fascinating comparison between the International Harvester 560 and John Deere 4020. While the IH560's C264 gas engine routinely clocked 20,000 plus hours without major overhauls, the John Deere 4020's legendary power block diesel pushed beyond 30,000 hours when properly maintained. Both 1960s powerhouses exemplified an era when overbuilt simplicity trumped computerized complexity. The timeline of agricultural durability tells an interesting story. In 1965, a basic IH560 tractor cost a farmer about $5,500, equivalent to a new car. But that investment often powered through 3 decades of service, making it arguably more cost-effective than today's high-tech replacements. For farmers who grew up hearing these engines purr across dawn-lit fields, they represented more than machinery. They were trusted partners in the daily struggle to feed a growing nation. Their reliability wasn't just about mechanics, it was about peace of mind. Want to discover which other tractors earned legendary status for their seemingly immortal power plants? Let's dive deeper into these mechanical marvels that refuse to quit. Number 10. John Deere PowerTech Series. When did agricultural engines truly begin to revolutionize farming? The John Deere PowerTech Series, introduced in 1996, marks a pivotal moment in engine evolution. These powerhouses, ranging from 2.9-liter to 13.6-liter displacement, brought together decades of engineering expertise with cutting-edge technology. The PowerTech PSS 6.8-liter variant, priced at $21,500 in its 1996 debut, delivered an impressive 140 to 200 horsepower while meeting Tier 3 emission standards, a feat that left competitors scrambling to catch up. Performance was not just about raw power, though. The PowerTech's variable geometry turbocharger, synchronized with a high-pressure common rail fuel system, created an industry benchmark for fuel efficiency, consuming just 212 grams per kilowatt-hour at rated power. Remember those early morning starts? Farmers particularly appreciated the cold start technology that had these engines purring to life, even in sub-zero temperatures, thanks to their innovative glow plug system and advanced electronic control unit. Maintenance innovation became another hallmark of the PowerTech series. The 500-hour oil change intervals, unheard of in the mid-1990s, saved operators nearly $1,200 annually in maintenance costs. Number 9. Caterpillar C Series engines. How did Caterpillar redefine industrial power in 1990? The C Series engines emerged as titans of torque, with the flagship C15 delivering a commanding 475 to 625 horsepower at its launch, priced at $24,500. These mechanical masterpieces featured a revolutionary cooling system utilizing a high-capacity water pump, flowing at 300 liters per minute, maintaining optimal operating temperatures even in the harshest conditions. Deep within its robust frame, the C Series boasted advanced electronic fuel injection technology, precisely metering fuel at 2,000 bar pressure. This engineering marvel resulted in fuel consumption rates of just 195 grams per kilowatt-hour at rated speed, a 15% improvement over its predecessors. The signature yellow block, crafted from compacted graphite iron, provided 75% higher strength than traditional cast iron, while reducing engine weight by 200 kilograms. Modern C Series engines embrace digital integration while maintaining their legendary durability. Each engine now comes equipped with Caterpillar Product Link technology, enabling remote diagnostics and performance tracking. The latest models feature advanced air management systems, delivering peak torque at lower engine speeds, 2,100 Newton meters at just 1,400 rotations per minute. This combination of raw power and intelligent control continues to make the C Series the backbone of heavy industry worldwide. Number 8. Ford 9N engine. What made the 1939 Ford 9N engine a turning point in tractor history? Priced at just $585, this 120 cubic inch 2.0-liter marvel delivered 24 horsepower at 2,000 rotations per minute, making reliable power accessible to small farmers everywhere. Its innovative L-head design, featuring detachable cylinder heads, pioneered serviceability in farm equipment, allowing repairs to be completed with basic hand tools in the field. The engine's cooling system was equally groundbreaking, employing a belt-driven water pump and four-blade fan that maintained steady operating temperatures even during extended operations. Fuel efficiency stood at an impressive 3 liters per hour under normal load, a remarkable achievement for its era. The 3 main bearing crankshaft, precision-balanced and supported by replaceable inserts, provided exceptional durability while requiring minimal maintenance. Simplicity defined the 9N's design philosophy. Its side-mounted distributor and generator arrangement offered easy access for maintenance, while the pressurized lubrication system, delivering 30 pounds per square inch of oil pressure, ensured reliable operation. The cast-iron block and head, with its replaceable valve seats and guides, contributed to many units surpassing 10,000 operating hours. Extraordinary longevity for the period. Number 7. The Massey Ferguson 4400 Series, launched in 2003 at $35,500, merged mechanical reliability with digital precision. The 4.4-liter power plant delivered 75 to 120 horsepower through an electronically controlled direct injection system, maintaining optimal fuel delivery across all operating conditions. Performance centered around torque optimization. The advanced Bosch fuel injection system, operating at 1,600 bar pressure, achieved peak torque of 460 Newton meters at 1,400 rotations per minute. Fuel efficiency reached 205 grams per kilowatt hour, setting new standards in its class. The 4-valve per cylinder design, coupled with a wastegate turbocharger, ensured consistent power delivery from idle to maximum speed. Service intervals stretched to 400 hours for engine oil changes, reducing annual maintenance costs by $1,500 compared to previous models. The engine block, constructed from high-strength cast iron, featured integrated oil channels and a structural sump design that enhanced overall rigidity. Electronic sensors monitored critical parameters including oil pressure, coolant temperature, and fuel consumption, displaying real-time data through the tractor's digital dashboard. Number 6. The Allis-Chalmers 190 Series engine, introduced in 1964 at $4,800, embodied American engineering excellence. This 301 cubic inch, 4.9-liter diesel power plant generated 93 horsepower at 2,200 rotations per minute, establishing itself as a workhorse for medium-sized farming operations. The inline-4 configuration, with its 7-bearing crankshaft design, delivered exceptional smoothness and durability. Cooling efficiency came from an oversized radiator and thermostat-controlled water pump, maintaining optimal operating temperatures even during extended cultivation periods. Fuel consumption averaged 4.5 liters per hour under normal load, competitive for its era. The direct injection system, operating at 2,000 pounds per square inch, provided reliable cold starting and consistent power delivery across the operating range. Performance testing revealed impressive results at Nebraska Tractor Test Laboratory, where the 190 series demonstrated 72.88 drawbar horsepower, exceeding its rated specifications. The engine's governed speed of 2,200 RPM provided optimal balance between power output and component longevity, while the innovative oil filtration system, featuring a full-flow filter with bypass protection, ensured reliable operation even under extreme conditions. This power plant became the backbone of medium-sized farming operations across the American Midwest, its distinctive exhaust note becoming synonymous with dawn-to-dusk productivity. Number 5. Valtra S Series engines. When did Scandinavian ingenuity revolutionize agricultural power? The Valtra S Series engine line, launched in 2008 at $72,000, showcased modular engineering at its finest. The flagship 8.4-liter power plant delivered 270 to 405 horsepower through an advanced common rail injection system, operating at 2,000 bar pressure and achieving peak torque of 1,540 Newton meters at 1,500 rotations per minute. Durability stemmed from innovative metallurgy. The engine block, crafted from compacted graphite iron, offered 75% greater strength than traditional castings while reducing operating noise by 3 decibels. Electronic engine management monitored 32 parameters simultaneously, adjusting fuel delivery and boost pressure to maintain optimal performance across varying loads. Fuel efficiency reached an impressive 198 grams per kilowatt hour at rated power. Maintenance intervals extended to 600 hours for engine oil changes, reducing annual service costs by $2,200. The modular design allowed for cylinder head service without removing the entire engine, while the integrated oil cooler and filter assembly simplified routine maintenance. Each engine underwent a 12-hour test cycle before installation, ensuring reliability from day one. Modern S Series engines feature Valtra Smart technology, enabling remote diagnostics and performance optimization through satellite connectivity. The selective catalytic reduction system reduces emissions while maintaining power output, meeting Tier 4 final standards without compromising performance. This blend of rugged construction and intelligent control systems exemplifies Valtra's commitment to advancing agricultural engine technology. Number 4. Fendt Vario engines. How did Fendt redefine agricultural power in 2006? The Vario engine series, introduced at $82,000, merged Deutz engineering with Fendt innovation. The 7.8-liter power plant generated 220 to 360 horsepower, utilizing dual turbochargers and an advanced common rail system operating at 2,200 bar pressure. Peak torque reached 1,450 Newton-meters at 1,450 rotations per minute, perfectly matched to Fendt's stepless transmission technology. Environmental leadership drove design choices. The selective catalytic reduction system, combined with cooled exhaust gas recirculation, achieved Tier 4 final emissions, while maintaining 192 grams per kilowatt-hour fuel efficiency. A variable geometry turbocharger optimized airflow across all operating conditions, ensuring responsive power delivery from idle to maximum load. Maintenance intervals extended to 750 hours for engine oil changes, setting industry records and saving operators $2,800 annually. The electronic engine management system monitored 45 parameters in real time, predicting maintenance needs before failures occurred. Steel-crowned pistons and strengthened connecting rods enabled sustained operation at maximum power without compromising longevity. Today's Vario engines incorporate Fendt Connect telematics, enabling remote diagnostics and performance optimization. The hydraulically actuated valve train adjusts timing based on load conditions, maximizing efficiency while minimizing fuel consumption. This combination of precision engineering and intelligent systems continues Fendt's tradition of agricultural innovation, delivering power with unprecedented efficiency and reliability. Number 3. Same Deutz-Fahr engine. What marked the evolution of European powertrains in 1995? The SDF Power Series, launching at $45,000, introduced a 6.1-liter engine generating 150 to 300 horsepower. Its high-pressure common rail system, operating at 1,800 bar, delivered precise fuel control while achieving 200 grams per kilowatt-hour consumption rates. Performance centered on a reinforced engine block featuring integrated oil galleries and structural ribs, increasing torsional rigidity by 40%. The 4-valve per-cylinder design, combined with electronic wastegate control, maintained optimal boost pressure across the power band. Peak torque reached 1,200 Newton-meters at 1,600 rotations per minute, ensuring steady power delivery during heavy draft operations. Maintenance innovation included 500-hour service intervals, reducing annual costs by $1,800. The modular construction allowed cylinder head service without transmission removal, while integrated sensors monitored critical parameters through the SDF power control system. Wet cylinder liners, plasma-coated for enhanced durability, contributed to service lives exceeding 14,000 hours. Modern SDF engines feature intelligent power management, automatically adjusting output based on implement demands. The advanced emission control system combines selective catalytic reduction with cooled exhaust gas recirculation, meeting Tier 4 final standards while maintaining optimal fuel efficiency. This marriage of traditional engineering and modern technology continues SDF's legacy of reliable agricultural power. Durability testing tells a tale of unmatched resilience. Each engine underwent rigorous 500-hour endurance trials before leaving the factory, operating at maximum power in conditions that would break lesser machines. The modular construction approach allowed for quick maintenance, with technicians able to access critical components within minutes rather than hours. When paired with Same's transmission systems, these engines achieved a remarkable 92% power transfer efficiency, a testament to German-Italian engineering prowess that would influence agricultural machinery design for decades to come. Number 2. John Deere 8. How did John Deere revolutionize large-scale farming in 2010? The 8R series engine, launched at $92,000, introduced the 9.0-liter PowerTech PSS, generating 245 to 410 horsepower. Its variable geometry turbocharger, operating at 2,200 bar common rail pressure, achieved peak torque of 1,800 Newton meters at 1,600 rotations per minute. Efficiency defined its operation through integrated power management. The electronic engine control unit processed 60 sensor inputs simultaneously, optimizing fuel delivery for 189 grams per kilowatt-hour consumption. The selective catalytic reduction system reduced emissions by 95% while maintaining full power output. Hydraulically actuated fan drive adjusted cooling based on demand, reducing parasitic losses. Service intervals stretched to 800 hours for engine oil changes, saving operators $3,200 annually. Cylinder heads featured replaceable valve seats and plasma-coated cylinder liners, extending engine life beyond 16,000 hours. The integrated diagnostic system provided real-time performance data through John Deere Operations Center connectivity. Current 8R engines incorporate predictive maintenance algorithms, analyzing operating patterns to prevent failures. The intelligent power management system automatically adjusts output based on implement demands and field conditions, delivering optimal performance while maintaining efficiency. This combination of robust engineering and advanced technology establishes the 8R series as the benchmark for modern agricultural power. Number 1. Valtra N Series engines. When did Finnish engineering redefine mid-range power? The Valtra N Series engine, introduced in 2015 at $65,000, featured a 4.9-liter power plant, delivering 115 to 201 horsepower. The common rail injection system, operating at 1,800 bar pressure, achieved peak torque of 800 Newton meters at 1,500 rotations per minute. Performance focused on versatility. Electronic engine management monitored 28 parameters continuously, adjusting fuel delivery and boost pressure for optimal efficiency. Fuel consumption reached 195 grams per kilowatt hour at rated power, while the advanced air management system maintained consistent power delivery across varying loads. Maintenance intervals extended to 600 hours for engine oil changes, reducing annual costs by $1,900. The modular design featured easily accessible service points, while wet cylinder liners and reinforced cylinder heads ensured durability beyond 12,000 operating hours. The integrated diagnostic system provided real-time performance monitoring through Valtra Smart technology. Modern N-Series engines incorporate EcoPower technology, allowing operators to select between high power and economy modes. The selective catalytic reduction system meets Tier 4 final emissions while maintaining full power output. This combination of compact design and advanced features exemplifies Valtra's commitment to practical innovation in agricultural power. Engines are the lifeblood of tractors, defining their endurance and capability. The iconic models we've explored are testaments to engineering excellence that have withstood decades of use. From the International Harvester's brute strength to the John Deere's unwavering dependability, these engines epitomize the resilience of farmers worldwide. These powerhouses aren't mere machinery, they're steadfast companions in agriculture's rich narrative. As we've seen, from the Farmel's versatile power plant to the Massey Ferguson's globally trusted heart, each engine tells a story of innovation and adaptation. The Fordson's pioneering spirit lives on in modern tractors, while the Case's robust design continues to inspire reliability in contemporary models. In an age of rapid technological advancement, it's crucial to appreciate these enduring engines that have shaped farming history. The Allis-Chalmers' unique sound still echoes in the memories of many, while the Deutz's air-cooled ingenuity remains a marvel of engineering simplicity. These engines have plowed fields, planted crops, and harvested bounties through generations, becoming integral to the fabric of rural life. The longevity of these engines isn't just about durability, it's a testament to the symbiotic relationship between farmer and machine. Each oil change, each careful adjustment, and each repair has been an act of trust and dedication. These engines have responded in kind, powering through droughts, frosts, and bountiful seasons alike.